Hello and thanks for watching Best Maths Tutors. We're continuing to go through the Edexcel Higher Tier paper from 2019, and this is paper 3. And we're going to cover all the questions on this. So if you'd like to see more of these, then click the subscribe button at the bottom here. So we're on question 16, and what it tells us is here are the first 6 terms of a quadratic sequence. So the -1, 5, 15, 29, etc. And we've got to find an expression in terms of n, the nth term of this sequence. So some of these can be quite difficult. First of all, in understanding what does it mean by the nth term, and what do we mean by quadratic sequence as well. So we could look at what a sequence actually means first of all before tackling the question. So if we were coming up with a formula, we might have something like, we might say the nth term is equal to something like just 3n plus 2. And this isn't this particular sequence. This is what I would call a linear sequence. And n stands for the position. So n is the position in the sequence. So if you understand all this, you can sort of skip forward to when I go on to actually answering this question, but I'm going to explain this a little bit first of all. So the nth term in this case, this sequence I've just made up, is given by 3n plus 2. So if I wanted to find the first term, then what I would do is I would make n equal 1. So if I do that, I would get 3 times 1 plus 2. So that means replacing the n by the 1. And I can see that the first term in the sequence would be given by 3 times 1 being 3, plus 2. You can see that the first term in the sequence would be 5. And for this sequence I'm making up, if I want to find the second term, then what I would do is for the second term, n is just a position in the sequence. So I would say that n would be 2. And this time I'd be looking at 3 times 2, replacing the n there by 2. I'm just putting that in a bracket so we can see that that means n is 2. So we're going to put plus the 2 there from the formula, this bit. And so we times the 3 by 2, we get 6. And then we would add the 2, and that would give us 8. So we started to build up a sequence here of numbers. We've got 5, 8, and if we did the third term, just do this here, third term. So for the third term, n would equal 3. And so we just substitute that into the formula. So we'd have 3 times 3 now, because n is 3, plus 2. So we'd get 3 times 3 is 9, plus 2, which is equal to 11. So that gives us the next term in the sequence. And we could keep going. And for this one that I've made up, we would actually be going up in 3s. And so that's actually the number multiplying the n here, tells us we'll be going up in 3s. So the next one would be 14, and then 17, etc. So if we were asked to come up with an expression for the nth term for this sequence, then what it would be the nth term would be equal to the 3n plus 2. So we're being asked in this question to come up with a formula like this for the position in the sequence. Okay, so like n in each case, n is 1 for the 5, n is 2 for the 8, n is 3 for the 11, n is 4 for the 14. So n just stands for the position in the sequence. Okay, so we've got our sequence here, and we have to come up with some formula like this for it. Now, the only difference is that this is a quadratic sequence, and what we have here is, this is what I would call a linear sequence. So a linear sequence is usually where the nth term is some number, so I'm going to call it a times by n plus another number b. So a and b are numbers. But if we have a quadratic sequence, as in the question here, then the difference is, whereas a linear sequence goes up in even steps, so we can see we added 3 each time, and so the formula would be a times n plus b. For a quadratic sequence, it doesn't go up in even steps each time, so it doesn't go up in even steps. And the general formula for a quadratic sequence is a n squared. So I could say the nth term, of that out, the nth term for a quadratic sequence would be equal to a, where a is a number that we would need to find, times n squared. So the squared is what makes it quadratic, plus b times n plus c. So a, b, and c are numbers which we would need to find, and n we've got an n squared in it. So quadratic sequences have an n squared. It's similar to a quadratic equation where that's got an x squared in it. Okay, so what I'm going to do is I'm just going to, if you've understood, if you know this already, you could actually skip up to this point, and now I'm going to show you actually how to do this question. So I'm just going to clear the screen off. So now we're going to look at actually answering the question. So we've got our quadratic sequence, and as it says, find an expression for in terms of n for the nth term in this sequence. So we're looking for the nth term formula like this. Nth term is equal to, and as I said just before, it will be in the form an squared plus bn plus c, and where a, b, and c are numbers that we need to work out. So the first thing we could do, I'm just going to rewrite this sequence again. 1, 5, 15, 29, 47, 69. And the first thing to do, so step 1, is look at the differences between each term. So we make another row, which is our first row, and we look at the differences. So differences on first row. So we can see to go from -1 to 5, we actually add 6. And then from 5 to 15, we add 10. Then it's 14. Then it's 18. Then it's 22. I might have spotted a pattern there, but we can see that the first row difference isn't actually the same all the way across. And if that's the case, then that indicates we've got a quadratic sequence. So now we look at, so step 2 is look at the second row differences. Okay, so we're going to do that. And if we look at all them differences, we can now see that to go from 6 to 10, we've got 4 is, we'd have to have 4 on from 6 to 10. From 10 to 14, it's 4 again. 4 to 18, 4, etc. So we've got a constant number on the second row, and we can say actually to find the value of a in our nth term sequence, in our nth term formula, a is equal to half the second row difference. Okay, so we've got half the second row difference. We divide that by 2, so a equals 4 divided by 2, which is 2. So we're partly along the way now. So we've got that the nth term is actually equal to 2n squared plus bn plus c. Okay, and there's a couple of methods we could use. I find my students find the easiest one where we create another row of we take our sequence. So I'm going to write this out again: -1, 5, 15, 29, 47, and 69. And then we create another row, which is now what 2n squared is. So we can work out when n is 1, 2 times 1 squared is just 2. And we create this line here, which is what 2n squared is. So for n is just the position in the sequence. So for the second position in the sequence, we've got 2 times 2 squared. So 2 squared is 4. So we've got 2 times 4. That means that's an 8. For the third position in the sequence, we've got 2 times 3 squared. And that would give us 2 times 9, which is 18. For the next position in the sequence, we've got 2 times 4 squared. So that's 2 times 16 equals 32. So we can fill that in. So we've got 2, 8, and then 32. So we can write that there, 32. I'll do the next one as well. So for the fifth position, so got 2 times 5 squared. So for that, we'd get 2 times 25, and that would equal 50. For the next one, we've got 2 times 6 squared. 6 squared is 36. 2 times it would be 72. So we can see what we've got. We've got our original sequence here, original, the one from the question, and then we've worked out another sequence, which is 2n squared. So I'm just going to tidy up the board again. So now our next step, step 3, is what we're going to do is we're going to take this row of 2n squared and take it away from the original. So step 3 is going to be subtract the sequence that we've generated by using 2n squared from the original. So if we do that, so we've got to be careful with minus signs here. We've got -1 take away 2 gives us -3. And then we've got 5 take away the 8 gives us -3 again. And if we continue, we can see actually every term is -3 there in this next row. So we've generated another sequence, and what we have to do is come up with a formula for this sequence now. So step 4 is find a formula for the new sequence? Well, in this case, it's actually simple because it's just -3. So in this case, it's just that the nth term of this actual sequence is just -3 because it's the same all the way through. So we've just got -3. And then what finally, so the final step is we actually just bring together the two sequences. So step 5, bring together the two sequences. In other words, that means the one that we had previously, which was our 2n squared. So we've got for the overall sequence, we've got the nth term is equal to the 2n squared that we had for the quadratic part. So this is this bit, 2n squared, and then the formula for the second part of the sequence, this -3. So that's it. It's the nth term is 2n squared -3. So I'm just going to quickly just say what I've done again. So step 1 is look at the differences. Go to the original sequence, so here, look at the differences on the first row. So this is a first row difference here, first row. So these numbers weren't the same. So then we looked at the second row, which was here. And then because that number is the same all the way through, what we do, we divide it by 2, and that gives us the value of a, the number which multiplies the n squared. So that gives us this value here. And having got that, so that meant we knew that a was 2. We got a new sequence generated by 2n squared here, and we subtracted that from the original sequence, and that gave us this -3 all the way along. Sometimes that might be a slightly more complicated sequence. It would always be a linear sequence, so we might need to find that. But in this case, it was just a single number all the way across. So we found a second sequence. So this is the second part of the sequence, which is the -3. So this bit here, and we bring them two together, the 2n squared and the -3, and that actually gives us the formula for the nth term. So we finished it. So that's it. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel. And for more help, visit our website, which is bestmathstutors.co.uk. Thanks for watching.